All right, let's go ahead and get started. Welcome everybody. So today we are planning. I am planning to do an in-class lab today. I thought my TAs would be here with the laptop card already, so if they don't show up, it'll be interesting. So hopefully we get to that. Okay, so a couple of administrative things. First off, just another reminder of some upcoming deadlines. We've got the group project checkpoint on March 28th. You guys asked about having an auto grader set up in Gradescope for that. I asked Sokwa about it, and signs point to no. That's what the Magic 8 Ball says. So I'll work on that though, because I don't know how we're gonna test. Oh yay! Okay. I don't know how we're gonna test your code otherwise. So I'll talk with him more about that. The other thing is that the paper reports and the slides are due April 4th. So we talked about that last time. Hopefully I cleared that up. April 4th for everybody, including the slides. Unless there's some extenuating circumstances, but they've got to be extenuated. It can't just be like, oh, I forgot. Okay. Grades for homework 1 are finally posted. Sorry about that. That was quite the saga, right? Grading homework 1 and getting you the grades. Sorry about that. It's just, yeah. That's what you get for trying out something new, a new grading system, right? So we have regrade requests open for the next week. I think we've done a pretty good job of being pretty clear as to why you missed any points. So I'm hoping there won't be very many of those, but in case you feel the need. So after today's lecture, I will be posting the next programming assignment on email forensics. This is not a difficult programming assignment. You might laugh at that statement, but it really isn't. Some research yesterday on what it would actually take to program this assignment after I had written most of the project, the description. If you do it in Python, like, you don't even need an external library. There's libraries in the standard library that will allow you to do the email analysis I'm asking you to do. So it's really not that difficult. And I have links to stuff that will help you. So I will post that. I may not actually go through it today. Might not be able to get to that so we have a guest speaker on Thursday. So it might not be until Tuesday that I can actually step through what I'm expecting and everything. But I am posting it today. And then the initial, I'm planning on it being due April 11th. So 1 week after your paper reports are due. Okay. Yes, question.
If it's a very easy assignment to do in Python, can we get bonus points if we do it in something obscure?
No. No. Why would I give you extra points for doing something the hard way? In the end, all that matters is that it works, right? So, yeah. Any other questions? Yeah.
I just want to clarify. I think you mentioned it last time. Are we actually submitting our midway point for the project, or is it are we submitting for a grade?
No grade. So this is mostly just a milestone to make sure that you are on track. Like if by the end of this month you don't have a program that can verify that the blockchain file exists, and then we're in trouble, right? So this is an effort to help you not save it to the last minute. It will not be reflected on the final. Any other questions? Okay, a couple of review questions from last time's lecture. Remember we were talking about image forensics. So What is the big difference between a vector graphic and a bitmap? It's a big difference. Yes.
Graphic based on equations, shapes, and
Exactly. Yeah. So vector graphic is a description, a mathematical description of what should be displayed using geometric shapes. And then it's the responsibility of the graphics card to interpret that and render it properly. Whereas a bitmap tells you exactly what each pixel should look like. Very good. How many different values does an RGB color store for each color? How many different values does an RGB color store for each? Yeah. Yes.
256.
256. Yes. So going from 0, which is black, if you have 0, 0, 0, that's black, all the way up to 255. You have 3 255s, that's white. Right. The most color, the most light output. Very good. What is the difference between a JPEG and an EXIF image file? What's the difference? Yes? The EXIF file contains metadata. So I did do a little bit more research into this. I kind of toyed with the idea of delving back into the topic of image forensics and exploring this, and it's complicated. So it's not just a bunch of metadata posted at the beginning of the file. It's actually because that would violate how the JPEG standard encodes data. So because it has to be consistent with a JPEG file, it has to interleave the data throughout the file in areas where it won't actually affect the rendering of the actual image. So it's not straightforward, just dump a bunch of ASCII data at the beginning of the file. So, and that sounded like a pain to go through and not very informative for your sake. So, but today we are going to do a lab where you'll explore those differences. So I actually want to start with the lab. The fact that that clock never moves throws me off sometimes. So this lab should not take very long because SOQUA, we don't have an actual image, correct? Disk image, correct, okay. So I need to make a Google Doc or Google Drive link and I'll put it up here. So why don't you go ahead and get your laptops. And we're just going to take a half hour to do this. So we're going to be done with the lab at 3:45, okay? Oh yeah, so if you don't want to use the laptop, one of the laptops we've given you, especially since we don't have an actual image, you don't have to. All you need is a hex editor on your computer. So if you don't have one, come and get these laptops. You don't need a hard drive this fast. Do you want this? Yeah.
Install in the directory. It makes a virtual environment. It's like let's make this a virtual environment. For this file.
Will you look it up?
Work for me. reason I hired the only thing that's possible
I got it. I got it. Oh, that.
I can write down the board.
Yeah, that's a great idea. Let's do that.
Trust issues.
Yes, that's the one. Okay. Take what?
So now, then I can make a second one. So you pass in the previous here, and then you can see state is. I should try that. I haven't, and I think it throws an error. Good job. Invalid does not mean like it's not going to hold much in or like you're trying to make an initial one.
Okay.
Right.
So we're trying to make the best with what we got, right? So thank you for your patience. Whew. All right. Oh man, we have a broken. Okay. So I don't know if you can see, is that big enough, that URL, big enough to read? People in the back? Ish. Okay. So that is a link to a file that you are going to analyze. Originally the intent was for this to be a file that was embedded, that was stored in a forensic image of a disk, and that you would need to open up the file system in FTK or something like that. It actually works, which has been a huge obstacle. But open it up, find it, and then try to figure out what this file actually is. So everybody having success downloading this file? Okay, so for security purposes, it was actually supposed to have the file extension .exe, but it's changed so that some download settings are finicky about that. So it's supposed to be an exe, and your job is to figure out what's going on with this file. All right. So let's say that you've been contracted by a company to see if there's been a theft of intellectual property by an employee. You found this file on, let's say it was sent an email or something, where we don't have an actual image, so we're making it up, right? So we've seized the employee's hard disk, created a disk image, and I happened to point you at this file. So you believe that there's a picture of a newly designed boat that was stolen, okay? So that's your first clue, and your objective is to see if you can recover or view the intellectual property that has been stolen. Ready, go. If it feels vague, that's because it's supposed to be at the beginning, but we'll get a little bit more specific as we go along.
/ capital SUD. Yeah, capital S U V. Oh, sorry.
Capital Sierra, capital Uniform, capital Zulu.
And then lowercase r, and then capital H.
Yes.
Capital.
Unless you really don't want
Oh wait. There's no. Inside the ED file, there's as you can see. Leave this line off.
So it might actually be helpful if you can pull up the slides on image forensics. There is something that will come in handy. I'll give you that as an unofficial.
I think we need to look for the beginning, so JPEG files have like 110. Figure out. So short names. It uses the buttons FF8 to denote common JSON. I might be like iceberg.
Can't fail twice. So my brother, when he was doing his PhD composition, yeah, oh yes, yeah. So this is electrical engineering at the beginning. So there's an oral part and a written part, and the first time he took he's passed. I think it passed his oral exam, but he failed his written exam. So we had to retake it 6 months later, and he passes his exam. Like he's quit swap. So because anyways, they decided that since he passed an oral exam and written exam, that was good enough. So they passed it.
You give them a for yours, you did the comp with
It literally says at the top of it, it literally says like chapter DFT image, C in chapter 2. So the intellectual property information
consider this supposed to be That close to food, so that gives you a little more.
I guess that's the.
Okay, what are you guys trying?
Open it up.
What are you having success with anything?
Reading some cool stories.
Doing what?
Reading some cool stories.
All right. About,
We each have put this fight in
what?
I didn't realize, I didn't remember that that was accident. I don't know if it was accident. They said the pro
Also gonna be Alex.
Not sure if this doesn't fall in my PC. Is that
So it says. It says JPEG has one perception of it, and then followed by another type of
I don't know. It's not,
I only find the one. It's like a 0 1. 0 1 is not.
So here's another clue. The all valid JPEG files have an end of image mark, so like almost like an end of file EOF mark. Right? So end of image mark of FFD9, as in these should be the last 2 bytes in the file. And the header should start with these bytes. And if you need to have, you need to get a hex editor, you can try out this one. I cannot vouch for it personally.
Yes. Course of this semester, and I published what I've done is I've not told us to collaborate on everything. It's done on. So we're supposed to somehow extract all this stuff, but they don't have that. So we don't have.
What is the card of the soul?
So someone.
They're actually asking for everybody to make a 1-minute video.
So much is like not.
They have no leverage. Everybody's already accepted. They have no motivation to create this video. It's still interesting.
Was that the only?
Talking about paper? Well, the open people are asking for videos.
Okay, how's it going? Good.
Splitting it into 2 credits. Now, everybody see it. I bet nobody's going to watch it. They have no session because wait, did you say right word?
You might really be able to.
Yeah, I can do that.
What did I do?
I watched the entire series. I watched 3 or 4 Marvel movies, and I even saw Marvel movies. So yeah.
Okay.
Yeah.
Maybe we should do it.
Who has a hex editor working on their computer? Who has the image open in that hex editor? Who has figured out how to change the bytes in the hex editor? Okay. Okay, those of you that didn't raise your hand for the last question, keep pressing forward because you're on the right track. You can just figure out how to change the bytes that are telling Windows that it's not a JPEG, so that Windows then thinks it is a JPEG, and change the file extension. Here we go.
I think I have enough projects.
So should we be trimming off?
Then I have.
There's bytes that come
What's that? He's looking at underground forums. Apparently, it's amazing possible. If you wanted to collaborate with me like 2 years ago, you can do Codco. I don't know. They're related to something. Yeah, that's what I do. My Ethernet paper, you could combine it with this paper, put it probably on. Nothing explaining.
I think personally,
Maybe this is the one I know.
I know what you're saying.
Anybody got the image yet?
Trim everything.
So you can get minus extra credit for asking you questions.
Because I know I'm working things off. Oh, wait.
So how many of you have found an existing end of image mark FFD9 in the file? By your estimation, is there anything else significant after that? No. Or is it just nonsense? So I hear there's 3 instances of FFD9?
Yes.
And does it look like they're, before the FFD9, is there, like, or before each one of them, does it look like JPEG data? Before 2 of them? Before 2 of them? What if you copied out those bytes into another file? You have a good
You scared me wrong, Robert. Oh, you're friend.
FDA, right?
Giving while I go throw up.
So close.
Okay, 10 minutes. 10 minutes. Get cracking. Anybody have it yet?
Yeah.
Yeah?
Yeah.
What do you have? What is it supposed to look like?
Not really close.
Does it look like a real phone?
Alright, that works.
It's like, it's kind of a mode, I guess. I guess it's a
Why is the company so mad at that?
Are there more than one?
No, I don't think it's the only one.
Yeah.
I remember something else.
That was the goal, right?
I remember
That was the goal, right? Getting that in.
that looks familiar, but it doesn't look as familiar as another image.
Oh, yeah.
You direct me and I can very quickly work on it.
Not everybody was able to get the
Yeah, that's really just a Windows only program. Yeah, the old version.
Yeah, it's a Mac there, I don't think anybody got
We've been scheduled for the classes now. They kind of linked the numbers. What happened was, it used to be a Friday only class. They had it scheduled for 209, but then they're like, well, if we're gonna get an adjunct to teach it, it's gonna be better, we're probably gonna have a higher chance of getting someone actually be able to do it like in the afternoons rather than. And so when they went that change, they forgot to make sure that the rooms get saved.
Oh, it's right here?
That was there was talk about switching classes.
Rated classes do that. Maybe they
All right, 5 more minutes. Anybody else have it?
Are you submitting to Usenix?
No, Usenix is already passed.
Right, so everything after that, just like mark, right?
And then you just like.
None of the rest of it works.
We get tired of reading the same stuff.
And then this, these need to be the first So there's one that might be this one. So if you cut out everything after the first, and put it into another, remove anything from the beginning of the first and balance, from the next F59, cut that. If something looks like this, but might be a little bit messed up, that's what I'm doing. This isn't going to be there. This signature is going to have some magic values. It's called a magic number. That is what identifies it as a JPEG. It has been altered. To make it this.
More than a year, you start to find some.
Yeah. Where does ASCII stop?
Yeah, they're actually accepting more papers. They're getting more submissions, they're accepting more papers. Wait, shit. 83 papers this time.
Looking for.
Is this when you do
No, the month I submitted, the total was 83 for all the sections. The month I submitted, 60 questions and
There are a lot of people that do forensic stuff that are regular.
I'm very nervous because I accepted in the first attempt.
But it's not.
The only possible result is equal or worse.
Maybe this has to be some kind of something that drives that workflow.
Yeah.
Okay, just a couple more minutes. Anybody else have an image they're looking at? You looking at a boat? Anybody looking at a boat? Nobody's looking at a boat? You got a boat? You got a boat? Yeah, it does. Yeah. See the boat. Anybody else have a boat? Did you find a second image?
The last 5 hours is second. Yeah. But the rest of the last like these 4.
Still.
I've had it.
I remember I saw that. Yeah, we did that.
We did this. We don't know where to stop this.
This is the one that comes out. Maybe just try.
We don't know how far down to go. It doesn't seem like these are modified slightly. Okay, so initially we did like just here at the end. And then this is like a very small image. This is like a couple hundred bytes and we stuck it in there. So we must have stopped like way lower than this.
I think that It might still render even if.
It gets kind of a mess. I try because I was like, oh, this is like a thing.
So who has a boat? Who has seen a boat? Like 3 people? You got one? No? You what? Okay, so I want to transition into talking about the next topic. So I'm not going to tell you to put your laptops away, but I think that would be the responsible thing to do. Otherwise, you'll be distracted. What's up?
Are you gonna like tell us how to find the boat?
Yeah.
I did. I just told you. You didn't hear me when I was talking? It's just a matter of understanding that this has to be the beginning and this has to be the end. And if you can get those in the right place, then it should decode properly. And part of this right here, part of this is ASCII letters EXIF, right? So that's one of the things that you can look for. Yeah. Yeah. Okay, so today we're going to talk about email forensics. There we go. Okay, who's ever used email before? Okay, just trying to draw your attention back. So we are going to talk about email forensics today. Email forensics was one of the earlier topics that I did research on, and it's actually really interesting. It's nice because email has a pretty well-defined structure, and so you can leverage that structure to understand what's going on in the email, right? So we're going to talk about that a little bit more as we get into this. But if you think about email more as a system than just like a single message, then it's got a few different components that make up an email system. The first is you've got user agents or webmail. This is where you can do composing, editing, reading email messages, mail servers that send and receive the email on the user's behalf, and then the protocols such as SMTP, POP3, and IMAP4. These are the different on the wire protocols that the mail servers use to talk to each other and exchange the actual message that you wanted to send and get it to the recipient. So here are some of the components that make up email as a system. So here are some application layer protocols. So I don't know how much networking background you have, but networking is made up of a ton of different protocols, right? If I'm going to send you data of any kind, we need to know the format that data is going to come in, and you need to be able to interpret it. So we have to have an agreement or a protocol for how data is going to be structured when it's sent over the wire. So down here at the very bottom, this is like the physical layer. Then you get higher and higher. So 1, 2, 3, 4, right? Layer 3, layer 4, layer 5. Everything on top here is application protocol. So it's been a little while. So saying that right, yeah? Be something, I can't remember. So what we're talking about as far as like transferring email between different systems are these here in the red box. We've got SMTP, POP, and HTTP that we use. So SMTP stands for Simple Mail Transfer Protocol, and it runs on port 25. POP3 is Post Office Protocol, and it runs on port 110. and then IMAP for Internet Message Access Protocol. These are just different ways of talking about email on the network. And sorry, one second. Okay, there's lots of different ways that you can access email. Hopefully this is all like super rudimentary, but you can use a standalone application which then communicates using POP3 or IMAP4 to receive or download emails from a mail server, and then use SMTP to transmit outgoing emails to a mail server. So Outlook, Thunderbird, and something that Apple puts out that I don't know the name of and don't really care. These are all different applications that reside on your physical machine and do the exchanging of email data with the server on your behalf. Maybe any of you've done this before, configured an email client. So this is obviously a screenshot from Gmail, where you can go into the settings and actually enable IMAP access, which allows you to. So normally you access Gmail. That's maybe not normally, but one of the main ways of accessing Gmail is to go to their website, right? But if you wanted to have a local program have an archived copy of your emails and everything like that and do all the exchange for you, this is how you do that, is you enable the IMAP access right here, or top, or all this cool stuff. So this is how you actually do the configuration. This, I can't remember, I think this might be Outlook, it might also be Thunderbird, I'm not 100% sure, but all of this, the most critical piece of information here is the outgoing mail server that needs to be talking SMTP for the client to actually communicate well with it. Yeah, why would I spend so much time talking about email clients if it's stuff that you've already learned or experienced in the real world? Think about this from a forensic standpoint. Why am I talking about configuring Gmail for IMAP in a forensics class? Yeah.
Standard way the clients are going to save it?
Yes. Yeah. Well, save it. No, actually. Why am I talking about configuring a local email client in a forensics class? Yeah.
Because if we get access to someone's hard drive, they have a configured local email client, we could like access it, or there's stored emails or something to that effect.
Yes, exactly. So if your suspect had an email client locally configured to communicate with a remote email server, that data is going to be stored on that hard drive. It's going to be accessible for you to analyze when you're doing your forensic analysis, right? The cached copies of their emails are there. Maybe their credentials, at least the service that it's talking to is going to be discoverable through a forensic analysis of the disk, right? That's why we're talking about it. I don't want to just talk about stuff that doesn't seem like it matters. I want to make sure we have that framing of the information of why are we learning this in a forensic class? Yeah, question?
If they have like a local mail client configured, is it legal for, I know like to like read the data would be legal, but like would it be also legal to like access like the mail server with their credentials that you have access to as an investigator and like do things on that mail server in the course of your investigation, or like what's like the legality of that? What do you have to do? Or is that like considered unreasonable search procedure, so you can do it if you have a warrant, or like, you know?
Sorry, I'm laughing because these are the very issues that I explored in the paper on email forensics that I wrote several years ago. Is it one of our papers? Yeah, it is. It's one of our papers. So, spoiler alert, no. Basically what we did was I said, hey, there's been all this research on analyzing Outlook PST files, which is your personal storage table, I think. That is the file format that Microsoft Outlook stores emails in when it locally caches them, right? Tons of research on it because Outlook dominated the market, especially in the 90s, right? Which was the golden age of forensics. You remember we talked about that? Simpson Garfinkel coined that term. So, but there hadn't been very much research done on, okay, what about webmail, where the typical use case is accessing this through the web. What I actually figured out was how to reuse browser cookies to do exactly what you were just talking about. So here, the credentials are going to be stored by the program, the email client, right? Somewhere in its configuration, somewhere. In the browser, when you open up your web browser and go to Gmail, right? You don't have to log in if you visited there recently because your credentials, a form of credentials, are stored locally by the browser as cookies. So I said, well, can we reuse these cookies and log in? And it turns out you can't. So as far as whether it's legal, getting back to your original question, I don't know. How's that for a long answer to say no? I'd say I don't know. But the purpose, the reason why is because number one, I'm not a lawyer. Number two, is it unreasonable search and seizure or violation of privacy if that data has been already kind of collected or parts of it are already on the evidence you're analyzing? It's a gray area, right? But even though I may not know if it's legal or not in every circumstance, if you remember, well, so Agent Gibbs kind of referenced to the fact that sometimes the importance of a prompt response is more important than getting a warrant, right? There are certain circumstances under which if you have evidence that a life is in danger or something like that, you don't have to go through the same procedures to get authorization to access evidence. So that was a caveat that I put in the paper is under the instance of being able to have prompt response for one of these scenarios, we went ahead and figured out how to do this, even if it may not be completely legal in every circumstance. I know that was a really long answer, but I think it's an interesting topic. So, sorry. Any other questions related to that? Okay. Let's keep moving forward. So, client email server roles. Email used in two environments, open or controlled. So we've got open meaning that anybody can create and use these accounts. Controlled meaning more like in a corporate setting where you are given an email account, not just you go and sign up and figure out if the username is still available, kind of a thing. So both use a client-server architecture where there's a central server that distributes email to many distributed clients. Like that is the architecture of email. So continuing on with this, the client's email software has to be installed, maybe installed separately from the OS, meaning they have their own directories and data files that the email software does. It may use existing elements such as browsers, and typically runs specialized software. Yeah. Trying to remember if there was anything else I wanted to talk about on this slide. Okay, so let's use a diagram to kind of illustrate what we're talking about here. So here we have this email client right here. So this one, And actually, this isn't a very good picture. I don't really like this picture very much because this inbox, this computer that's labeled inbox, or it's actually not. You got to think of this as the server that that the recipient has an account on, not the user's computer themselves. Okay, for this diagram to make any sense, otherwise it gets really confusing. So you have an email client like Outlook that talks to the inbox, and it says to the email server, "Do you have mail for me?" And then yes, here it is. So I think this one's actually better. So here we have Alice and Bob that are communicating with each other. And this, Alice's computer communicates over a LAN or a WAN to the mail server via SMTP. Because the email is going from Alice to Bob. So outgoing is going to always be SMTP. So then this mail server talks with Bob's mail server, also over SMTP. And then Bob is communicating with his mail server via POP3 or IMAP4. Sorry, the diagrams in these slides are a little bit wanting. I apologize for that. Any questions on this? Yeah.
So the mail server in this diagram represents something like Google's Gmail server, for example.
Yes. Yes. And then the assumption is that the recipient of the email has a mail server, has a different email provider is a better way of putting it. So Bob is not on Gmail, it's on Yahoo or MSN, something like that. Alta Vista, yeah. All right. In case you've never seen a screenshot of webmail before, let's just ponder this for a second. No, I'm just kidding. Here's an example of webmail, but here, let's actually talk about how this works. So this is a slightly different use case. So here we have Alice using an HTTP client on her computer. So there's some HTTP transactions that go on between her browser and the web server, the HTTP server of the email server for the email service provider that she subscribes to. Okay? The web server talks with the SMTP client, and that SMTP client talks to Bob's site, the SMTP server on Bob's site, that then gives the information to the HTTP server so that Bob can then send a web request using his browser, talking to the web server, not the email server, of Bob's site and retrieve the message. Yes?
I thought SMTP was only for outbound, so why would the SMTP servers be talking to each other?
Why would they be talking to each other?
Yeah.
Okay, so SMTP server, so SMTP is the protocol, right? And SMTP server is just another way of saying email server.
I just thought that the SMTP was only for outbound mail.
Yes,
for
the SMTP protocol is for outbound mail.
Okay.
Yes, but in order to provide email, basically SMTP server, that term is synonymous with email server. Okay. SMTP service can communicate with other protocols other than SMTP. Okay. Does that clarify? Good question. Okay, let's go a couple more slides. All right. Hopefully this is illustrative if the projector works. This is drawing an analog between an envelope and an email. So on the left, we have an envelope with the return address up in the top left, the recipient's address in the middle, and then the contents on this blue box indicating actual message that Mr. Musharraf wants to send to that recipient obviously didn't make these images, but we're just gonna roll with it. Okay, so if we were to translate this into an actual email, the envelope actually is part of the SMTP protocol that we actually, I have another diagram that, that describes it next. And then this from and to is part of the email header. So this envelope, it's separate from the actual email contents itself, even the header, it's separate. And then you have the actual body of the message. So the header and the body compose the entire message. Okay, so to illustrate, I don't know what MTA client is. Mail transfer authority. Nice. That's why I have TAs. Okay, so the client is sending something to the server. So this first part is the envelope where we say, all right, we're sending this is coming from this person. We get a 250 OK, which is just a protocol code saying, yeah. Okay. And then the recipient, the receipt is going to this address, and then the MTA server says, yeah, okay. Now the client sends some data. What data is this? What data is this? You know what data this is? The very first two? Step number 5? No? Okay.
So it's agent, not authority. Just
okay.
Close enough.
I don't know what data this is. If I don't know it, I'm not going to quiz you on it, right? That's the rule of this class. Then the MTA server says, okay, go ahead and start sending the actual email. And the 7, 8, 9, 10, these are all the headers. There's actually a lot more headers that will probably be included in this. We'll take a look at some examples in just a second. And then a blank line. This is actually this is a required part of sending an email. You have a whole bunch of headers where the field name, and colon, and then the contents of that field, line after line, and then a blank line. Blank line indicates if the next thing is coming is the start of the message, the actual body of the message. Okay? And then, I guess, you got a single dot or something, and then that's the end of the message. Okay? Questions on this protocol? Okay, so some differences between corporate versus public email. This is for forensic purposes, right? So if we're going to trace corporate emails, it's going to be a lot easier because the names of corporate email addresses are typically standardized, right? Think about your ASU email address. It has components of your name in it, right? My ASU email, mmaybe, is my first name initial, and then my last name up to 5 characters, which thank goodness my last name is 5 characters, because don't envy you guys that have longer last names, because it's like part of the last name, especially if you have a last name with 6 letters, it's like everything in my last name but the last, I'm sorry, that's rough. But that's a corporate email that was assigned to me by the organization I'm part of, and it's derived from my name. So it's a lot more easily traceable than my personal Gmail account, which is just my first name and how tall I am at gmail.com, right? That's not as easily traceable. I picked that. There's no one that said, okay, this has to follow these naming conventions. And usually they're not informative unless you want to know how tall I am. And then, no, I'm just kidding. All right, identifying email crimes and violations. So the term crime can obviously refer to different things based on the jurisdiction that you're in. For example, Washington State has an actual law against spam, but not necessarily other states. So there you go. But email crime is becoming commonplace for all these wonderful just getting terrible things that people like to do. So how would you, as a forensic examiner, identify email chains that relate to narcotics trafficking? Yeah.
I guess in the simplest case, if you have access to the mail server that they're using to.
Let's assume that you already have the entire contents of their mailbox.
Oh, yeah. And you could maybe do like a search for common words that you.
Keyword search. Yes, absolutely. What else could you do? See, the problem with keyword search, which is actually a major part of your email forensics homework assignment, the problem with it is that if it's not exact, it's hard to find what you're looking for. Yeah?
That's where grep comes in.
Grep?
Grep.
Yes, but grep has its limitations too, right?
Yeah.
No? So, even grep is still pretty, it's an exact match search algorithm, right?
I think regex.
So if I'm looking for all emails that have to deal with financial transactions,
Regex.
then you do, that's exactly what I'm saying, right? You have to put in terms like money, cash, dough, like all the slang terms that refer to just money. But then there's implicit references to money, possibly, right? Like account number. Well, that might not actually be a finding account number, or I mean, could or could not. So it's difficult, right? You know, you think it's still solve all the world problems, right?
Could you search, like, look for specific file types that were attached in emails? So images, videos.
Yes. So email attachments are kind of its own thing, right? Because if we go back a couple slides, oh, I'm going forward, sorry. So the email protocol was designed for just plain text, right? The original RFCs that have to do with email, just plain text. So adding attachments came on later. It was kind of an add-on later. So they had to kind of come up with clever ways to include data, file data, along with the contents of your email. So the answer is yes, but it's not as straightforward as just reading the body of the message. So yeah, exactly. Yeah. Go ahead. Yeah.
Okay, you can hire someone to go through all the emails for you.
You must have a lot of money. Okay, so if we're going to examine the email messages, the first step was we got to actually have access to the evidence, to the email messages, right? And we could use the email, the suspect's email client, find and copy evidence in the email, access protected encrypted material, and even carve emails. Why would you want to carve? Term carving, does that make that? We haven't talked about carving, huh? Let's just skip it. I don't want to go into that today. Okay. You know what? Let's. Do you want me to very quickly show you your assignment?
Sure.
Let's stop here as far as lecture slides go. And pull that up. Come on. Okay, so this will be posted later on today. When I post the stuff from today's lecture. Okay, so the basic idea here is that you're going to write a program that allows you to search for keywords in a body of email. So Specifically, what we're going to look at is the Enron data set. I think I mentioned in a previous lecture how the Enron scandal was all about the emails, right? It was all about the emails. So because of that, it is the most widely analyzed email data set because it's publicly available as part of the investigations that took place. So I have a link to the actual Enron email data set and a link to how to convert it to what's called an MBOX format. MBOX is really great because it's basically just a flat file, flat text file. So there are ways to get at the attachments, but this assignment doesn't have anything to do with attachments. Okay, so you're going to program something that can do keyword searches. These links will basically do half of your assignment for you. I'm not joking. It's awesome. I didn't realize that it was that good, but hey, it's all good. Okay, so you're gonna call your program Enron search, and then just when you invoke it, you just give it at least one term, and it's gonna look for that. It's gonna be case insensitive, but exact. So all of these will yield the exact same results, right? So money, all the cases, it's case insensitive. We're not doing any fuzzy matching, no fuzzy matching, which means if you do a search for the word the, it will not match them. Okay, and yeah, so this is what your output should look like, and at a high level, that's your programming assignment. Questions? So when you find one of the search terms, you're going to look through all the email and all the terms that are given. So all of the terms that are typed in have to be in the email. So if there's one that's not found, you can just skip it and go on to the next email. Okay? When you find a message that contains all of the search terms that were provided by the user, you will print out the number, the result number, the name and email address, which is this format is just like it is in the email header, so you shouldn't have to do any transformation. Just grab the sender field, post it right there, and then the date. And this format, same thing. That date format, you don't need to adjust it. Just grab the send date from the email headers and print it. And then keep a total and print out how many results you found. Okay? Questions? Yeah?
Do we need to be able to support strings that include spaces?
No. Because if you look up here, so the program specifications state that you have a term and then optional more terms, right? And then here, all of these will yield the exact same results. So the order does not matter, just the actual words matching case insensitive. Okay? What do you think? Good? I'm excited. All right, we'll see you guys on Thursday. We have a guest speaker, so we'll see you then.